Okay, so hey, how are we doing today? We're gonna be skipping over a few sections. The last topic we covered was 2.1, which was working with inequalities and graphing them on a number line. Today we're gonna be skipping 2.2 and 2.3 because for some reason, when we do multi-step inequalities, we then go back to one-step inequalities for two sections, and then back to multi-step. And I think at this point, it's just unnecessary to move back like that. We're gonna jump straight to 2.4. It'll be a really quick and easy day today, so let's go ahead and get started. I am out of a blue marker, so we're gonna do green. We're gonna see how that works. Hopefully you can read it. 2.4 is solving multi-step inequalities. So I have 2.4. Okay. Now inequalities, just like equations, sometimes they produce an answer. They can either be infinitely big or infinitely small. And this is what happens when the variables disappear while we're working it. Just like in section 1.3, when we were working with equations, if the variable disappears, it tells you it's something special. So before we get into that, let's make sure that we understand all the other stuff. So inequalities. Will sometimes produce an answer where the variables disappear. This means your answer is either infinite with an identity, or non-existent. So what we're looking at right here is we either have an identity, which means we have infinitely many answers, or we have an empty set, which means we have no answers. So before we get into that, let's make sure we got a good basis of how do we do an inequality and how do we graph it on a number line, and make sure we know the nomenclature for what's going on with these types of problems. So number one is y divided by -6 plus 7 is less than 9. Number two is 2v minus 4 is greater than or equal to 5. And number three is 6x minus 5 is less than 2x plus 11. Okay, so now with these three inequalities, again, the first thing that we're always going to make sure we're paying attention to is how are we working through these? Now remember, we're always following PEMDAS as we simplify each side, and then after we've simplified both sides, we follow PEMDAS in reverse. So if we simplify the left and the right, parentheses, exponents, multiplication, division, addition, subtraction, and then I work it backwards, and I come out of it. Now the first three right here, there's really nothing that we can simplify because as I look at it, there's nothing that I need to do here. So I'm just gonna go ahead and start reversing the process to get rid of everything on the variable side of the equation. So I'm gonna subtract 7 from both sides. That's gonna cancel that out. Y divided by -6 is less than 2. Next thing I'll do is I'll multiply both sides by -6. That'll cancel that out. Now remember, we talked about in 2.1, when we multiply or divide by a negative, that's going to cause the sign to change direction. So instead of opening to the right, this is now opening to the left. So y is greater than negative 12. So when we take our number line, and I put my negative 12 in the center, okay, I'm going to go ahead and I'm going to put a circle on my point of interest. So I have my negative 12 right there, and I'm going to plug in value. Now some people look at what direction the arrow is pointing in. Don't worry too much about that. Plug in the values and see if it makes the equation true. Does negative 13, is that greater than 12? No. Negative 14? No. But negative 11 is greater than 12 and negative 10, all these over here. So anywhere where your equation is true or your inequality is true, we're going to make that part of the graph thicker. So like these 2 points we know make it work, but anything I could plug in between there are also true. In fact, everything on this side makes my inequality true, so I'm going to shade in everything over there. And lastly, even the things that are not on my number line, the things that are off, I'm going to thicken up that part of the arrow to show, hey, everything over here on this side of the inequality. The last step is going to be it. Is the negative 12 also included in my answer set? So plug it in. Is negative 12 greater than negative 12? The answer is no, so I'm not going to shade in the negative 12 as part of my answer set. For the next one, I'm going to have a slightly different response to that, but let's see how that works out. So same deal's going on. Left and the right are fully simplified according to PEMDAS, so I'm going to slowly get rid of the parts of my equation that are connected to the v on that side. Get rid of subtraction by doing the addition, so I add 4, so I have 2v is greater than or equal to 9. And then I'm going to get rid of the multiplication by dividing, and I get v is greater than or equal to 9 halves. Now that's the proper form for our answer, but on the number line, I don't really care where, I don't really want a 9 halves. I want to know, okay, what is 9 halves as a decimal? 9 halves for us is going to be roughly 4.5. It's actually exactly 4.5. So on my number line, in the center, I'm going to put 4 and 5 roughly in the center. So I have a 3 and I have a 6 as well. I'm going to go ahead and put a circle where my number line is centered, which is right there between the 4 and the 5. And then I'm going to plug in values and see, hey, is it going to make my inequality true? If I plug in a 3, 3 is not bigger than 4.5, and neither is 4. But 5 is, and 6 is, and every number over here is greater than 4.5, including the numbers that I have that are not listed. And lastly, I'm going to say, let's plug in the 4.5. Is 4.5 greater than or equal to 9 halves? And the answer is yes. So we shade that in. So we see that when we have an or equal to, we shade in the circle. When we don't, we don't. And lastly, number 3, as I work this, I have a variable on the left and on the right. So I'm like, okay, which one do I solve for? Do I solve it for the left or for the right? And the answer is it doesn't really matter. So you get rid of one of them. Now most classes, in fact all classes, got rid of the 2x. Could I get rid of the 6 though? Yeah, I could get rid of the 6 and get it solved the exact same way. So it doesn't really matter which one you get rid of as long as you get rid of one of them. So 6x minus 2x is going to give me a 4x, and a 4x minus 5 is less than 11. Now that I have an x on the left, now I can finish solving the inequality by adding the 5 to both sides. That's going to cancel that out. I have a 4x is less than 16, and divide both sides by 4, and I get x is less than 4. Lastly, I'll go ahead and draw my number line. I'll put a point at 4, 5, 6, 3, 2. Go ahead and draw my open circle at 4, and then I'm going to plug values in. Is 3 less than 4? Yes. Is 2 less than 4? Yes. Everything over here, including points in between the numbers, are less than 4, and anything over here that I haven't included on my number line in that direction is less than 4. And I'll try and plug in a 4. Is 4 less than 4? The answer is no, so I'm going to leave that as an open circle. So these are what we call conditional inequalities, or conditional statements. Sometimes it's true, sometimes it's not. So when I look at this, are these values true? Yes. Are these values true? No. Sometimes it is, sometimes it's not. Sometimes it's not, sometimes it is. The answer is, it depends. It's conditional. So just like in 1.3, these are what we call conditional inequalities. most of the time we consider those normal because that's typically what you're going to be solving for in Algebra 1. Now, on occasion, you might run into a few where they're not so conditional. Let's take a look at the next two. So number 4 is 8b minus 3 is greater than 4 parentheses 2b plus 3. And number 5 is 2 parentheses 5w minus 1.2 is less than or equal to 7 plus 10w. Now both of these, when you start working them, first thing you notice is I do have that first step where I have to simplify them. So on the right hand side, I have parentheses, nothing inside them that I can do, but I can distribute. So I'm going to go ahead and multiply everything inside there by 4, which leaves me with 8b plus 12 is less than 8b minus 3. So simplification, super easy. And then when I notice I have a b on the left and on the right, I got to get rid of one of them so that I can solve for the other. So I'm going to go ahead and subtract 8b from both sides. Now the problem is it gets rid of both of them. And I'm left with this statement right here. And I want to ask you, how often is negative 3 greater than 12? It's not. So this is a false statement, which means that this was built incorrectly. This is not a true statement up here, so we worked it and we got a non-true answer. You start with false things, you end with false things. Nothing happened here. So there are no solutions that will make this true. So I'm going to say no solutions. I can't spell English today, I'm sorry. No solutions, or I can just say this is an empty set. I don't care which one of those you put, but basically what you've done is you've solved the inequality and said, hey, negative 3 is larger than 12. That's not true. So therefore, nothing that I plug in for my value of b will make it true. Is negative 3 greater than 12? No. Is it greater than 12 tomorrow? No. Is it greater than 12 depending on what value I put in? No. It's just not true. So when I graph it, let's go ahead and graph this on a number line. I'm going to put my 2 hot points here, a negative 3 and a 12. You might be like, oh, I didn't know you could graph, a no solutions thing. So remember, this tells us what values will make this equation true. Will any values make this equation true? No. So that being said, we're done. We graphed it. Now, is there a part that I'm going to shade in? No, because negative 3 will never be greater than 12, no matter what we do, which is why my number line is empty. There's no values that will make it work, which is why it's called an empty set. It's empty of possible solutions. Here I have a bunch. I could plug in any one of these numbers and make that inequality true. Here, I can't plug in anything, which is why it's empty. Hopefully that's a better visual example of what's going on with an empty set. The last one, when we work this one, I can simplify the left-hand side. So I'm going to distribute what's going on in there to both of those terms. The 2 times 5w gives me a 10w. The 2 times negative 1.2 gives me negative 2.4, less than or equal to 7 plus 10w. Got a w on both sides. I got to get rid of one of them. Fun bit here. Doesn't matter which one you get rid of, they both disappear. And I'm left with something that says negative 2.4 is less than or equal to 7. And now, just like I did before, because the variables disappeared, that means that I'm dealing with something that is not conditional. It's either always or never true. And when we look at this one, how often is negative 2.4 less than 7? The answer is always. So we have true. There are infinite solutions. Or if we don't want to write infinite solutions, we can just go ahead and write identity. Either one of those works. Now, you can also graph this on a number line. You're like, wait, hold on, what? So negative 2 is between negative 3 and negative 2. Negative 1, 0, 1, 2, 3, 4, 5, 6, 7. There's my 7. Okay. Now, again, just like we did right here, I'm going to ask you what values can I plug in to make this true? So is negative 2.4 less than 7? Yes. If I plug in a 2, is negative 2.4 less than 7? Yes. If I plug in a -3, yes. If I plug in a 0, yes. If I plug in a 7, yes. If I plug in anything in between here, pause, wait, how often is -2.4 less than 7? Always. So I'm going to go ahead and I'm going to shade in everything. Even for numbers over here, is -2.4 less than 7? Yeah. What about for numbers over here? Is -2.4 less than 7? Also, yeah. So unlike my empty set, we call this infinite solutions because these are the values you can plug in to make that true. You can plug in anything you want, it's always going to be true. And that's 2.4. At this point, you should see like, oh, okay, that makes sense. This is why we skipped 2, 2, and 2, 3, because this is directly after 2, 1. So let's go ahead. Our homework for tonight is going to be, we're going to go to page not 175. We're going to go to page 75. And we're going to do questions numbers 1 through 10 odd. And these are going to be due tomorrow. So that's going to be 5 questions. You saw that we knocked out these 5 with me walking you through them in a very short amount of time. This should take you all about 5, maybe 10 minutes if you're really struggling, but realistically it should take well less than 5 minutes. It should take you about 2.5 if you're timing yourself. So hope that works out. I'll see you all tomorrow.